So let's see the question, and the question says a certain solution consists of Na2CO3 and NaHCO3. 30 ml of this solution required 12 ml of 0.1 normal H2SO4 using phenolphthalein as indicator. In presence of methyl orange, 30 ml of the same solution required 40 ml of 0.1 normal H2SO4. Calculate the amount of Na2CO3 and NaHCO3 per liter in the mixture. तो आइए इस क्वेश्चन को सोल्व करते हैं. First of all, we have to discuss about the key concept of this question. Basically जो क्वेश्चन है ये एसिड बेस टाइट्रेशन पे डिपेंडेंट है. So it is the acid base titration which is used as a key concept in this question. So आइए स्टार्ट करते हैं. और जब फिनोप्थलीन इंडिकेटर यूज किया गया था तब सिचुएशन को देखते हैं. When phenolphthalein is used as a indicator we can say that here the number of milli equivalent mass of H2SO4 which is used when phenolphthalein is used as a indicator, we can say that it is milli equivalent of H2SO4 which are used during the neutralization. So we can say that it is 12 ml which is the volume of solution given multiplied by, we can say that it is the normality and it is 0.1 normal. So here the volume is used in milliliter, that is why the gram equivalent we are getting from here are milli equivalent. So it is equal to 1.2 milli equivalent. After that, consider the equivalent moles of the component of the mixture. So let us assume A and B as milli equivalent of NaHCO3 and Na2CO3. Now in first case, when phenolphthalein is used as indicator, we can say that A is the mole of NaHCO3 and B is the mole of Na2CO3. Now when phenolphthalein is used as a indicator, NaHCO3 will not undergo neutralize. Only some amount of Na2CO3 will be neutralized and it's only half part. So we can say that from here the gram equivalent or milli equivalent of Na2CO3 which are used will be equal to B by 2, and this is equal to the gram equivalent or milli equivalent of H2SO4 used, and from above calculation we can say that it is equal to 1.2. So we can say that from here B is equal to 1.2 multiplied by 2. So it is equal to 2.4 milli equivalent. To the second situation, and here we are going to use methyl orange as a indicator. So when methyl orange is used as a indicator, then milli equivalent of H2SO4 which is used during the neutralization will be equal to, and here we have given 0.1 normal H2SO4, so these are the 0.1 gram equivalent. Now we have to multiply it by the volume and it is 40 ml. If we are using the volume in milliliter, then we will get 4 milli equivalent mass from here. As we know that when methyl orange is used as indicator, both NaHCO3 and Na2CO3 will get neutralized. So the milli equivalent moles of H2SO4 which are used here will be equal to the milli equivalent of NaHCO3 which is considered as A, and milli equivalent moles of Na2CO3 which is considered as B. So the sum of the milli equivalent of NaHCO3 and Na2CO3 will be equal to the milli equivalent of H2SO4 which is used. So it is equal to 4. Now we have already calculated the value of B. So it is 2.4 which we have to put up here, and it is equal to 4. From here we can calculate the value of A easily. So 4 minus 2.4 and it will becomes 1.6 milli equivalent of NaHCO3. So from here, from this milli equivalent, we can easily calculate the mass of NaHCO3 which is used. It is A is equal to 1.6. So what is A? It is actually milli equivalent of NaHCO3 which are used in titration. So it is equal to 1.6. From here we can easily calculate the mass, and it can be calculated as mass of NaHCO3 which is used. So we can say that it is 1.6, and because these are millimoles, we have to multiply it by 10 raised to power minus 3. After that we have to multiply it by the molecular mass of NaHCO3, and it is 84. So this is the mass of NaHCO3 which is used, and it is actually present in 30 ml. So to find out the mass of NaCO3 present in 1 liter, we have to use, we know that 30 ml of mixture contains 1.6 into 10 raised to power minus 3 multiplied by 84 gram of NaCO3 of NaHCO3. From here we can say that 1 ml of mixture contain 1.6 into 10 raised to power minus 3 multiplied by 84 and divide by 30 ml. And for 1000 ml we have to multiply it by 1000. So after doing the mathematics, we will get 4.48 gram which is present into per liter. So it is the amount of NaCO3 which will be found in 1 liter volume of the mixture. So now we are going to calculate the amount of Na2CO3 present in 1 liter volume of the solution. Now in case of methyl orange, complete Na2CO3 will get reacted with H2SO4. So milli equivalent mass of Na2CO3 will be equal to milli equivalent mass of H2SO4 used in this titration. As we know, as we have calculated in the previous part of our question, milli equivalent moles of H2SO4 are 1.2. So from here we can say that milli equivalent of Na2CO3 are 1.2. Now we have to calculate mass of Na2CO3 which is used into the titration. So it will be equal to 1.2 millimoles. These are 1.2 milli equivalent. That is why we have to multiply it by 10 raised to power minus 3 to convert it into equivalent weight. After that we have to multiply it by the molecular mass of Na2CO3, and it is 106. After doing the mathematics, we can calculate the mass of Na2CO3 in grams, but this mass is actually present in 30 ml. So we can say that if 30 ml contains 1.2 into 10 raised to power minus 3 multiplied by 106 gram of Na2CO3, then 1 ml of mixture will contain, we have to divide it by 30 ml, and after that we have to find out in 1000 ml, that means 1 liter. So for finding the amount in 1000 ml, we have to multiply it by 1000 ml. From here we can say that ml will cancel out with ml and we can do the mathematics. After doing the mathematics, we will get it is 4.24 gram per liter. So this is the final answer of this question. I hope you understood it.